Good morning, girls. Children, we are doing chapter Gravitation, and in my yesterday's video, I had explained you what is a freely falling object. Yes, I also explained you what is the meaning of the free fall, and we also studied about G. Okay, so a freely falling object means any object which is falling from a height under the influence of gravity is called a freely falling object, and this phenomenon is called what? Free fall. Then I also explained you that if suppose an object is falling from a height and there is a continuous change in the velocity of this object, and why there is a change in the velocity of the object? That is because of the gravity of the earth. Okay, and because there is a change in the velocity, change in velocity gives rise to acceleration. Therefore, we call this acceleration as acceleration due to gravity. Okay, so these were the points which we had discussed yesterday. So you go through those points, go through those definitions and learn them. Okay, now I also told you, means we also derived the formula for G. G is equal to GME upon RE square. This was the formula we derived. Okay, so remember that the acceleration due to gravity, this G is called what? Acceleration due to gravity is independent of the mass of the falling object. That means if there are suppose two objects falling down, one is a stone and one is a feather. Okay, so in both the cases what will happen? Acceleration due to gravity is acting. So acceleration due to gravity does not depend on the mass of any object. It is independent of the mass of the falling object. So it is same for all. And what is the value of that? G. G is equal to 9.8 meter per second square. So did you understand what I said? That G does not depend on the mass of the falling object. Okay, now this value of G, I'll give you one homework, you will complete that. Now according to this formula, you know that G is directly proportional to the mass of the earth and G is inversely proportional to the radius of the earth, square of the radius of the earth. Now you have to remember that the mass of the earth is constant. Okay, it is not changing, but the radius of the earth changes, due to which what changes? G changes. So I'm going to discuss these points now, but what is your homework? You write it down that the value of small g, there is a fixed value of small g and that is 9.8 meter per second square. Right? Now how we got this value? You will solve this and complete it in your notebook. G is equal to GME upon RE square. We know the value of capital G. We know the value of mass of the earth. We know the value of radius of the earth. So what you will do, you will substitute all the three values and you will solve it and find the answer for G. Okay, so that is why the values are 6.673 into 10 to the power of minus 11 Newton meter square per kg square. Then mass of the earth 6 into 10 to the power of 24 kg. And what is the radius of the earth? The radius of the earth is given by 6.4 into 10 to the power of 6 meters. Okay, so remember that these values you will substitute in this given formula and you will get the answer for G. It is equal to 9.8 meter per second square. Okay, so you will solve it and you will get this answer. Then most of the times we take the value of G as 9.8, but sometimes for easy calculations we take G as 10 meter per second square. Why 10? Because 9.8 is close to 10. When we round it up we get 10. Okay, so if it is given in the question that in the numerical that take the value of G as 9.8, then we will take 9.8. If it is not given, we can take the value of G as 10 meter per second square. Why? Because this will make our calculations easy. Fine. Now you know that acceleration is having the unit meter per second square. Similarly, G also has the same unit meter per second square. Because this is also acceleration, this is also acceleration. Okay, so these points are clear to you. Now, yesterday children, I told you that when I was deriving this formula, I told you that why do we take in this case the distance of the falling object as a radius of the earth. So I want to make it clear with this, like, you know that this is the shape of the earth. What is the shape of the earth? It is a spherical body. Okay, so this is also a ball, sphere. Now I was telling you that suppose an object is falling from a height. Okay, an object is falling from a height, and I told you to we take the distance of the falling object as the radius of the earth. So once more I want to clear that concept, that suppose the object is falling from this height. Suppose falling from this height. Now this height, if you compare it with the radius of this earth, we are talking about earth. So if suppose this is the distance of the falling object, from here it is falling down, this distance if you compare with the radius of the earth, it is a very extremely small distance, or a very negligible distance. Negligible means not noticeable. It will not affect your answer too much when we are solving this question, this type of these numericals. So therefore we ignore that and we take the distance of the falling object equal to the radius of the earth. Okay, did you follow what I'm saying? That the distance of the falling object is very small as compared to the radius of the earth. Therefore, that distance is neglected and the distance from which the object is falling down is taken to be the radius of the earth. Fine? Okay. Now, according to this formula, we know that G is inversely proportional to the radius of the earth. You all know, children, that earth is a spherical body. Okay? It is a spherical body. Earth is a sphere. But it is not a perfect sphere. You know why? Because it is bulging in the center and it is flat at the poles. So if we assume that this is the earth, there are two poles, north and south. So this part, and this is north, this is south pole, and this is the equator. So children, when you compare the radius of the earth at this point, which is what? Equator, and when you compare the radius at this point, that is the pole, don't you think there is a difference? Yes. So therefore, the radius of the earth keeps on changing from equator to the poles. Okay, because earth is a spherical body, but it is not a perfect sphere. Radius keeps on changing if we move from equator to the north pole. Okay, so when I say that if we move from equator to the north pole, the radius will go on decreasing, and if we move from north pole to the equator, the radius will go on increasing. Now I am talking about G. So let us compare the value. I told you some important points I want to tell you about G. We will write first. G is minimum at the equator as the radius is maximum. You know that if you compare the radius of the earth at the equator, this is a maximum length, and therefore since G is inversely proportional to the radius of the earth, therefore G will be minimum. So remember, G minimum at the equator. Second point is G is maximum at the poles. Poles maximum as the value of Re is minimum. Okay, so therefore if at the poles G is what? Maximum, and G is minimum at the equator. So remember this, about G. Number 3. You know that this earth has center. Okay, so center means no radius. When no radius means no G. So therefore we say G is 0 at the center of the earth. Okay, remember this. So as G is inversely proportional to the radius of the earth, when the radius of the earth is maximum, G is minimum. When the G is maximum, where at the poles, because the value of RE or the length of RE radius is minimum. And the third point is G is 0 at the center of the earth. Okay, so remember that these are the important points about G. Now, what next we have? Uh, Yeah, as I told you that G does not depend on the mass of the falling object. Acceleration due to gravity is same for all the freely falling objects. Whether it is a stone, whether it is a paper, whether it is a feather, whether it is any heavy object or any light object, the acceleration, the acceleration due to gravity is always same for all. It does not depend on the mass of the falling object. Okay, next. I hope these points are clear to you. Now you know that we have two G's in this chapter. What? Small g and capital G. Now I'm going to tell you some differences between G and G, and you're going to write down in your notebook. Okay, first one. What is small g? G is acceleration due to gravity. Okay, and what is capital G? This is a gravitational constant. Right? Number 2. G is equal to 9.8 meter per second square, but the value of G changes with the change in the radius of the earth. Okay, so we cannot say that G has a fixed value. Okay, on a surface of the earth, we take it as 9.8. Normally we take it as 9.8, but if we go at the equator, the value of G will change. If we go at the poles, the value of G will change. Fine. So we can write that G is equal to 9.8 meter per second square at the surface of the earth, but its value keep on changing depending on the change in this radius of the earth. Number 2 here, capital G has a fixed value. What is that? 6.673 10 to the power of, yes. Okay, then number 3. Any other point you know, if you want, you can discuss. You can think over it and write it down. So what is your homework? You have one more homework I gave you. This is another homework. Complete all the points of difference between small g and capital G. And I think it is easy for you to compare. You can also write, what else? G is acceleration due to gravity, gravitational constant. Yes, you can write the formula. You know that G is equal to GME upon RE square. And for this, you can write G is equal to FD square upon M1, M2. Okay, so if you get some more points, student, you can complete this. And what is the other homework? Your another homework is calculate the value of what? Small g, using the values which I have given you. Now, I have completed the topic free fall. I told you everything about G. And remember that I told you that in this chapter, whenever we are talking about acceleration, it will always be small g. So the three equations of motion, you can write now the 3 equations of motion for a freely falling object. You know that first equation is v is equal to u plus at. So I will write v is equal to u plus gt. Next. Acha, one more point I want to tell you about g, which you can add it in the notes what you are writing. Then s is equal to ut plus half gt square. And number 3, 2gs is equal to v square minus u square. V and u you know, t also you know, s also you know, everything you know. Wherever we had a, I have replaced it by small g. Now one more thing, I think I just left it out. When I was telling you the important points about g is positive. What is the value of g we take? 9.8 meter per second square. When we are solving numericals, g is taken to be positive for a freely falling object. Yes, but g will be negative when we throw the object upwards. Okay, an object thrown upwards. Okay, so what I'm trying to explain you is g will be same, the value will be same, but it will be positive and negative depending on when we are given any question. Suppose we are talking about, in a numerical, we are talking about any freely falling object. Suppose an object falls from a height. In that case, g will be positive. Okay, why? I'll tell you that also. And g will be negative for the object which is thrown up. You know that. Why? You know that. What is the direction of the acceleration due to gravity? In the downward direction. Okay, g is equal to 9.8 meter per second square. Okay, what is the direction of g? Downwards. So if an object is falling down, okay, the direction of that object is same as the direction of g, therefore it is positive. Okay, but if an object is thrown up, which is opposite to the direction of the acceleration due to gravity, then it is taken to be negative. So I hope it is clear to you that g is always acting in which direction? In the downward direction. And if the object is falling down and we are solving any question numerical, g will be positive, remember. And if an object is thrown up and that thrown up object is against the acceleration due to gravity or against the direction of the acceleration due to gravity, therefore its g, in that case g will be taken as negative. Okay, so g can be plus 9.8 meter per second square and g can be minus 9.8 meter per second square when freely falling object or a falling down object and an object when it is thrown up. So these are some points which you have to remember, and today whatever I have told you children, you revise. If you have any doubt, you can ask me. Thank you, have a good day and study this chapter very carefully. It is interesting also. Okay, and if you have any doubt, you can ask me. Okay, have a good day and revise well. Thank you.